Hello, good evening. Hi. Welcome to a different kind of episode. For once, I'm not on Linux, as you might notice. I'm on Windows, and we're here to try and fix a library of mine which attempts to provide automatic, or not automatic, it attempts to provide native audio output on all platforms, including Windows. And the Windows part is slightly broken. And so we're here to investigate that and hopefully fix it as well, but I can't make any promises about that. I could not figure out how the fuck to increase the font size on Emacs globally, so I'm gonna have to do things like that in all the buffers and stuff. So, you know, fun times. Alright. So, projects, harmony, drains, what's up? God damn it. And it increases it quite a bit, but whatever. Slightly in the sense that on some systems it works and on others it does not. For instance, inside the virtual machine that I typically develop Windows applications on, it does work. Not entirely perfectly, there's some hiccups, but it does work, and on others it just crashes. So, I haven't touched this code base in quite a while, so it's gonna take me a bit to get used to it again. I'm still kind of garbage at typing as well. As you may or may not remember, I switched to Dvorak, so yes. Lots of fun things. I hope it might happen that the audio output misbehaves and outputs garbage, which might be very loud. So this is my warning ahead of time in case bad things happen. Your ears might get blasted out. I apologize in advance if it should come to that. I really hope it does not. Alright. Right. So here's the deal. Windows has a couple of different sound APIs. And the reason for that is your old friend backwards compatibility. Now, for the systems that we care about, which is Windows 7 Plus, you have an API called WAS API. Windows Advanced Sound API, I believe, is the acronym. I'm not entirely sure. And previously, you used to use mostly Direct Sound, which is in DirectX API, but that's been deprecated. So deprecated. So probably not the best. And then there's a really old one back from, I believe the Windows 3.1 days, which you probably don't want to use. So WAS API is the thing we're going to deal with. Fortunately for us, this is a completely Lisp native implementation. So this does not use any C library at all. It binds directly to the OS APIs. On Windows, we do that through COM. So there's lots of CFFI COM stuff that's defined in another file. So the actual calling of the APIs is not that troublesome. It's a bit annoying, but it works. Now, the actual API itself is, as very often the case with Windows APIs, a huge pain in the ass, in the sense that it's convoluted and a lot of things don't make any fucking sense. But for the important part, the API offers you two different modes of operation. It gives you a shared mode and an exclusive mode. As you might guess from the names, the exclusive mode gives you exclusive access to a sound device. So while an application has exclusive mode access to a sound device, nothing else can play on it. Exclusive mode is also much closer to the hardware, so if you really need very low latency sound outputs, exclusive mode is for you. The other one, shared, allows you to play audio alongside other applications, which means it needs to go through an OS indirection where it buffers data. This is all fine and good, but for our purposes, the annoying part is that the exclusive and shared modes differ in how the buffer where you actually put your audio data is given to you. So in exclusive mode, you query the sound device for a maximum buffer size, so how much data you can unload onto it in one go. Then you get that buffer from the API, you get the pointer to it, you fill it, and then you say go. And then you wait until the buffer contents have been played back, and then you fill it again. On shared mode, things are a bit more problematic. On shared mode, you don't know how big the buffer is going to be. You get a maximum size of the buffer, and you can suggest a size that you would like to have. But as far as I can tell, Windows does not give any shits about the suggested size and just gives you whatever it wants. And even better, the size of the buffer can change depending on when you invoke, when you start playing back samples. So that's the Windows side of things. Now, on the side of Harmony, things are different again, and they don't exactly match up very well. In Harmony, you have, as it stands right now, which I am subject to change, as it stands right now, the audio engine basically outputs a fixed number of samples every iteration. So you say go, and it fills an output buffer with n number of samples that you can set. Typically, that's going to be a multiple of the sample rate that you pass. Typically, the sample rate is 4.41 kilohertz. No, 44.1 kilohertz, which is standard CD quality. And so typically the buffer is going to be like probably some like 441 samples. And the problem is now, because the Windows buffer that we get back is not going to be agreeable with the internal buffer that we picked, and it can change at any time, we need to play shenanigans. And so we have a sort of complicated logic to keep track of this. Namely, what it does right now, or what it should do right now, is it keeps track of how many frames we still need to write into the buffer. If there's 0 frames to write, we wait for a bit, and then we ask the OS for a new audio buffer, and we also ask it how big the buffer is going to be, because it might change. Right, so here we get the buffer, and then we make a round trip, basically asking ourselves, okay, do we have any frames that, or yeah, we call it frames here because it's multiple channels. So a sample is a single audio peak. A frame is basically a collection of samples for each audio channel, typically 2 for stereo. And then you have a buffer of such frames. Right, so next we check if our buffer is exactly right. Like the amount of frames that Harmony has generated is agreeable with the number of frames that we need to write into the OS buffer. If so, we can simply mem CPI this stuff over and we're done. If we have too many frames, we copy as much as we can, and then we go again and ask the OS for a new buffer. And that's basically done in a loop until we have no more frames from Harmony. And once that's done, this routine returns and Harmony goes again and processes its own things. So basically the generation of frames or samples is driven by Harmony, and we're doing this loop-de-loop in order to sort of synchronize both of them up. You might notice that this is problematic for several reasons. The first reason is that, as it stands, we might be grabbing an audio buffer from the OS, and then we realize we don't have enough frames in Harmony yet in order to fill this buffer entirely, so we have to go through the entire sample generation process, which might be costly. And then this buffer is maybe filled, maybe it has to do multiple round trips, and then it's sent back to the OS. So that's bad because that's latency. And in audio stuff, you really do not want latency. So this approach is okay, but it's not the best. What you would ideally do is you would keep a separate thread and a ring buffer that is filled by the Harmony thread and consumed by this thread that simply takes care of copying stuff over to the OS buffer. Alright, so that was a lot of talk, just explaining how things work, mostly also as a reiteration for myself so I know what's going on. There's a whole bunch of other shit in order to determine the audio device and get everything ready for playback, but this is basically how things work. Now, let me see if I can remember how to get a basic example up and running here. I think I'm just gonna load the simple interface for this. Oh, god damn it. I have on my new keyboard, I have a key that is usually unused, which I'm now using as a meta or control key, but because making custom keyboard layouts on Windows is actually hard, it doesn't work. So I need to get used to using the faraway control key again for things. And as you might know, Emacs is very heavy on those control keys. Alrighty, so Harmony simple. In case you're wondering, the audio story, the native audio story on other OSs is very different. On OS X, it is a pain in the ass again, and on Linux, it is beautifully simple and easy. Alright, start. God damn it. Alright, I need initialize. Okay, good. Alright, now it should be running, so we have an audio thread that is up. We should have ourselves a thing here in the volume mixer. There we go, that's good. Let's cautiously put things down a bit and maybe put that somewhere up here so that we can see it. There we go. Oh, god damn it. Is there no way to sticky things to the top on Windows? Is that not a thing? I don't think it is without extra tools. I can pin it to the taskbar, that's not the same. Fuck. Let me put it over here then. You won't be able to see it, but trust me, it's there. Alright, now we can play something back. Play. Whoa, no. Whoa, no. Don't scroll up. I think I have a music file prepared. Yes, there we go. And we'll put that on the music mixer. Default, is that, does it need a path name? Is that what's going on? Let's try that. Okay, there we go. Can hear it. And it actually sounds okay. It even doesn't have any hitches going on, that's very nice. On the virtual machine I was getting occasional hitches, where the audio was dropping out, probably due to delays introduced by this. So this is very nice. And now I'm kind of at a loss on what to do, because I don't know how to debug the problem. I know on Ginger's system it doesn't work at all. I don't know why. So, it had a loss. It might be due to the fact that it's on Windows 10, or it might be due to the fact of something that I have no idea about, potentially audio device differences. But yeah, on this basic setup it works just fine. Right. Stop. It's not necessarily that the hardware is mysterious, but Windows APIs are mysterious. Let me, just as a comparison, so just so you know, this is the code that drives the connection between WAS API and Harmony. So this is 300 about lines of code in order to do this. And this is in addition to the CFFI part, which defines all the stuff. So here we have another 600 about lines of crap that's being defined in order to talk to COM and in order to have all the things going on that we need. Windows, even like the most flabbergasting part of the API is the way you specify the format of your audio data, which is done through a WAV format spec, you know, for the WAV file format. Oh boy. And that's got a whole load of weird ass shit going on inside of it. So I don't even know where that is. Yeah, here we go. Format tag and stuff. Average bytes per sec. Why the hell would you need to know that? I don't know. Anyway, it's got lots of shit in there, and I don't even want to know. I keep pressing the fucking old control key. Yes. And by comparison, for instance, let's look at ALSA. ALSA has this CFFI file. It's 130 lines of mostly enums, which I mostly don't need, but it's here for completeness. And then you have 80 lines of actual code doing things. So really, this is beautiful. I was so happy when I figured out that this was easy to do. And the way the API actually works is really simple. Basically, you just tell it, okay, I want an audio device, give me one, and then you tell it, okay, this is my sound data that's going to be coming in. And then you just say, okay, every iteration you say, hey, here's this many samples, and here's a pointer to the data, play that shit back, and that's it. That's all you need to do. The same goes for Pulse Audio. Pulse Audio's interface is actually exactly the same, almost. You know, it has some differences, of course, but in terms of what you do, it's exactly the same. You open a device, you tell it the format, and then you play it back. Done deal. Beautiful. And yeah, so the core audio, which is OS X's things, is also it's not as bad as the Windows part, but it's again, the API docs for Core Audio were horrible, worse than the Windows ones. Like, it took me a long time to figure out what the fuck I was even meant to do. It's littered with weird options that you have to set and figure out, and what the hell you're even doing. And the way this is done right now, the way the actual thing is implemented, so in Core Audio, this is another paradigm to Windows and Linux. In Core Audio, you have a C callback that's being run by the OS, in which you need to fill their buffer with the requested number of frames. So you actually have no control over when frames are being played back at all, or anything like that. So you have, like, this is also stuff that's not within the thread of your own application. So this is called from the OS at whatever time. So we need yet another way of doing things. Basically what I'm doing here is really bad. I ask Harmony, I think I synchronized the number of samples that Harmony generates with the number of samples that's being needed for each callback. So I assume right now that every time this callback is called, I need the same amount of samples, which has in practice been true so far, but I don't think it always will be, so this is probably going to break at some point on some weird system. But yeah, right now I basically say synchronize the number of samples with the ones in Harmony itself, and then I just copy the buffer over and potentially wait, just sleep until the buffer is full, so I'm sure I have something. Again, the proper way to do this would be to use a ring buffer and use that to synchronize the two, but ring buffers are annoying and I didn't want to deal with it, so I didn't do it. Patches are welcome. Right, so then we don't need that either, nor do we need that. Yes, we don't need that. Okay, here we go. Right, so I'm not entirely sure what I'm supposed to do now, given that on my system things work just fine. Gingy, can you try to replicate this again, like using latest Harmony from Git and following the same method, which is quick load Harmony simple, call Harmony simple initialize, and then call play on some MP3 file. Okay, thank you. Again, I don't see anything theoretically that's wrong with my code, which is why I was so confused about it not working on his system. But I've had weird other audio stuff happen to me lately on Windows where I was using, for TTS, which is why it's not working right now, I was using a wrapper library called Ouch123, which is part of the MPG123 project, and that just stopped playing anything back some weeks ago. I didn't update Windows, I didn't change my software, I don't know what happened, it just stopped working. So things are definitely strange, and it seems to me that really every time I boot up Windows, something else goes wrong without my doing so. My preferred OS experience for sure. Do we have any more kludges in here? Harmony itself has, okay, allow picking device, right? And I wanted to add a way to say that you want an exclusive mode, so it has support for both. Harmony itself has a couple of issues in its design, or, well, I don't know exactly if issue is giving it the right name. I would rather call it maybe deficiencies? I don't know. So, because I like Kloss, I love it, I really do. So I do use class a lot. For instance, you might see here that the main function that actually does the processing, the copying of samples, is a method. And so Harmony does use class quite a bit, which is not great for latency because class is a bit more expensive than standard function calls. So far it hasn't been a problem, actually. In practice, I've been able to do things just fine running them. But that's like a thing that I've been sort of unsure about whether it's the best choice. You can bypass the class stuff. So I guess in the meantime, I'll talk a bit about Harmony and the system in general, since you might be interested in that. So Harmony is a... Well, let me pull up the thing here. The thing. Documentation, if you will. Here we go. Need to regen these docs. Whoa, whoa. What the fuck was that? Alright, I don't know. Anyway, Harmony is basically a sound server of sorts, and it allows you to do sound mixing and processing as well. Harmony is built on top of a bindings library to a C library that I wrote myself called Mixed. So most of the actual sound processing, the conversion of samples, and the application of mixing and effects and stuff is done in optimized C routines. Now, you might be shocked to learn this, given that I'm usually a Lisp purist of sorts. I wouldn't even call myself that. I just do what's working, but I like to use Lisp for whatever possible, hence also using native bindings for the OS things. But I tried writing a mixer that performed well in native Lisp, and I couldn't do it, probably because I just suck. But I ended up writing a very, very simple library in C that allows me to define sort of pipelines to do sound processing in. So CL mixed. CL mixed is the bindings library for it, and let's have a look at this. Right, so here's a basic C example. As you can see, it's full of boilerplate, as C will do. But essentially, the basic idea is preserved. So sound processing in Mixed happens through a sequence of things called segments and buffers. So buffers are containers for audio samples. So a buffer can contain, for instance, a sequence of let's say just a single channel of audio data, and then you have a channel per a buffer per channel of audio data you have. So for instance, here we have standard stereo. Then you have segments for sources and drains. Sources are, well, obviously they produce audio, so they don't have any inputs, and drains consume audio, so they don't have any outputs. And everything else is sort of in between and processes audio data in some way. And then you have things called unpackers and packers, which are necessary because different drains and sources have audio in different formats. So very often the audio format is going to be interleaved. So for instance, you have a sample for the left channel, a sample for the right channel, and then a sample for the left channel, and so forth. And since Harmony or Mixed operates on separated channels, we need to unpack that data. Very often the samples are also not floats, there are some kind of integers or something else. So the packing and unpacking performs the conversion of samples and even sample rate and things like that. So that we, inside of mixed, everything that processes samples always knows it's going to get a buffer of floats, and each buffer is going to be a single channel. So using that, processing audio data becomes very, very easy. And then you basically connect this pipeline of sorts by setting input and output buffers on the different segments, which connect internally to sort of locations inside structs. And then you add the segments to a sequence in the right order, and then you call start, and you call mix, and repeatedly, and then you call end, and then you're done. And you free things up. And that's the basic operating procedure of mixed. So we can also have a quick look at some example segments. What do we want to look at? Let's see, a generator generates sine waves. So basically, actually, before we look at that, mix.h. Sorry for the coughing, I've been kind of ill. You might notice that my voice is different. Alright, so this is stuff. Lots of flags and things for information. And metadata. Right, and then you have the basic segment struct, which is sort of a dispatch mechanism, standard procedure. You have lots of fields for function pointers, and this allows mix to actually be extended from list as well, because what you do is basically you allocate a struct of memory like this, and then you set the individual pointers to callbacks that you can define from within Lisp. And so in that way you can even define audio processing code within Lisp and extend things that way without having to ever touch C. Using this sort of generic method also allows the API to be general and extensible. So yeah. So for instance, in here we define some additional internal data struct where we keep the buffers and other kinds of information about how we generate things. And then we have the different functions to set the data within the segment, which is very boilerplate because C, and we don't have macros, so hooray. War inheritance, which will also help a lot. And then you have the basic mix function, which actually does the generation of the samples, and as you can see, it's basically just a loop where you fill things into a buffer and you're done. And then you have the standard creation function, which just allocates a standard segment struct, and then, as I said, fills the different pointers with the functions that we defined above. So that's the basic procedure of mixed. On the Lisp side, in CL Mixed, you just get a fairly straightforward mapping of everything in Mixed. You get some convenience functions that convert arguments, of course, and you get some safe nets, standard procedure stuff. It also implements a generic way of creating custom segments. For instance, here's a segment that performs an echo effect by simply repeating back a certain number of samples faded away, which actually sounds pretty okay, and it works just fine. So that's pretty cool, being able to add in segments like this. And then in Harmony, what Harmony adds to the whole thing is basically a way of disconnecting the main loop of audio processing. So it has a control thread where it performs audio operations, and it takes care of keeping track of different kinds of mixers and drains and sources. So that's what it does for you. Right. It also does take care of buffer allocation, so you don't actually need to care about the buffers like you need to do in mixed or CL mixed. All you say is how the pipeline connects to each other, and then it'll figure out the optimal allocation of buffers that are needed between individual segments automatically using a coloring sort of algorithm. Right. Again, you can add custom segments that do things, which is cool. Yeah, so that's Harmony. And Ginger reports that he only gets god-awful noise. And what the fresh hell am I looking at here? Please, Emacs. Okay, debugging god-awful noise is very difficult. Especially when I'm not sitting at the machine producing the god-awful noise. Do you have any other kinds of audio playback devices that you could test against? Visualize. Oh, fucking. Okay, it should be gone now. No, it's still there. Why? Oh, probably because Windows only registers the application once. Thanks for being aware of interactivity in applications. Cool. Okay, no other audio devices. Yeah, that puts me in a bit of a pinch. I don't know what to do about this. There's no real way for me to debug that. This is bad. But yeah, I don't. I guess the only way to start and debug this is to throw in some print statements and figure out how many frames that the API wants you to write and how many frames Harmony is actually able to write. So basically on entrance, you should look at frames to write and what else? Frame buffer size as well. And what else? Where's process frames coming from? Oh, here we go. And process frames as well. So process frames tells you how many frames Harmony has produced right now. Frame buffer size tells you the size of the buffer that Windows gave you, and frames to write tells you how many frames there are left in Windows's buffer to fill. And those things need to start matching up at some point. Another thing to check would be, I'm not sure, I do check all this stuff for error response codes at least, so it shouldn't be a problem of initializing the audio device. Yeah, I really don't know. What could be wrong? works. There's also this weird thing that I noticed where I tell Windows that I want to use something called event callbacks. So Windows has an API that allows you to basically block a thread until an event arrives, which is perfect for what we want to do because we basically want to sleep until the next buffer is ready. But in my experiments, I found that actually calling the function to suspend the thread here just returns immediately, always, in every case. Yeah, for whatever fucking reason I can't get the event waiting to work, it just always returns immediately. Which is not what we need, because in that case, we're not waiting long enough for the frames to actually be processed, so we're getting garbage values back. We need to back off for a bit. Yeah, I don't know. Obviously, the way I'm sleeping here is not, not perfect by any means, but at least it doesn't lead Harmony to eat up 99% CPU for no reason. I really don't know why the wait for single object doesn't work. It's used in several example codes that I could find, of which I could not find many. Well, it's used in the shared mode example, but not the exclusive mode for obvious reasons. But yeah, it's just odd. I think there's a bunch of stuff I'm not cleaning up if I read this code correctly, but that shouldn't really lead to any problems, just minor, very minor memory leaks. This is another weird thing where asking the Windows API for audio formats that are not specifically 44.1 kilohertz 2 channels float results in complete garbage. As in it results in really, really astoundingly bad quality audio. So I'm assuming it does some weird conversion somewhere internally that is really bad. I have no idea why it happens, but yeah. At least that's the case for shared mode. I've never actually tried exclusive mode, so I'm not sure what exactly goes on there. I think in exclusive mode, since you're talking directly to, or quote unquote directly to the hardware, probably just fails if it doesn't have the format that you want. Oh boy, all this crap. Interesting. Already initialized. You know, it should have called uninitialize. Audio client initialize. What? No idea what that is about. Let me check the... Should have kept the window. Okay. Here, what was it? iAudio render client. So we have a... iAudio client initialize. Okay. iAudio client. There's no uninitialize, huh? There's a stop. Oh my god, please. What is this shit? Oh my god. So we call audio client stop, render client release. Is there a reason we're doing it in that order? Probably to stop that. Right, okay. Maybe I need to call reset. Okay, no, that doesn't seem to be it. How do I uninitialize the thing? Because that's kind of important. Ooh, this is interesting. In Windows 8, the first use of iAudio client to access the audio device should be on the STA thread. Calls from an MTA thread may result in undefined behavior. STA thread meaning probably thread 0? The audio file is almost definitely not the problem. But let me try it anyway. Protocol. I don't know. It says Windows 8 though, not Windows 10 necessarily, so I'm confused. Alright. Anyway. I need to Oh yeah, I'm getting the same problem. Why? Default. That's odd because it should have loaded. That's some ASDF bullshit. God damn it. Because it should have loaded the WS API package already at this point, but it's not doing it for whatever reason. Great. Thank you, asshole. Okay, that works. I'm not hearing anything. Did my thing work? Yes. What is going on? Okay, interesting. Oh wait, I called stop globally. I'm a fucking idiot. That's why. Restarting again. Ah, boy. Yeah, it works just fine. Ah, fuck, I called stop again. God damn it. Anyway, let me check if there's a way to uninitialize. Oh, you need to release it and obtain a new one. I see. Okay. The render client release. Okay. Why is there no release for this? How do I release it though? How do you do this? Safe release render client. Safe release device. What's the device? Calls the release method. Okay. Why do I not have a thing for that though? Ah, fucking this goddamn shit. What the fuck? Ah, I hate this. My audio client. Property store. So it doesn't def construct. How the fuck? I thought that was. Oh, there we go. Clear interface release. Yeah, there it is. My audio client release. Is this not did I forget to export it? Is that all? My audio client. No, it is there. What? Why didn't I see it? Oh, it's just. Oh my god. ASDF. Why? Ah. Fucking really. ASDF is such a pain in the ass sometimes. Do I not have my dependencies right somewhere? Because this is, yeah, no, it is there. I don't get this. I really don't get this. This is like not in the features or something until... Is that the thing? Okay, so there's a Win32 feature. Okay, then we will do... There we go. Initialize. Okay. Stop. Gone now? Nope. Still there. Uh-huh. Not a system area pointer. Uh-huh. Ah, fuck you. It's not the thing I'm interested in. Next format is nil. Wait, decline is nil. Why? Decline nil. Decline is nil because decline is... Why is decline nil? Where is it set? Here it is. Client. I think I'll call initialize packed audio again. In start, just to be sure. I don't like this. This is annoying. This is really, really, really annoying. Though on the other hand, yeah, this is a pain. So the problem is that in order to know the format for which things need to be packed, I need to construct a client, and this is usually done on segment creation time. Now, because that could potentially change, because what the OS reports is supported might could potentially change, we would have to change the packed audio at some point. I could... The problem is you can't easily can't easily change these values. At least not as easily as one would like. How does com release work? I'm interested in that. Not just a direct C call? Oh, it does this trick. Nice. Can I change the sample size of an packed audio? Pack drain. I think I can. I'm not entirely sure. Let me check. So mixed packed audio. Line accessor. Size. Oh, we specified the size as well? Okay. Oh, right, this. Okay. Okay, so I think I can do this if I move the entire initialization into init. Pack drain. Packed audio. Okay, right. The only problem with that is querying the information is going to be wrong. Not that really should matter. Okay. Packed audio, buffer size, context. Size is number of channels, which is that specified in the context? I don't even know. Samples, buffer size, sample rate. Nope, it's not. Okay. Kind of feel like it should be. That is entirely not what I wanted. 2 sample rate. Let's just say the standard 44.1. Alternating sample format. Standard is float. 2. So we just make a best guess here. And then we move all of this to initialize. Or to whatever, start. Okay. Set up cell mixed channels. Okay, pack channels to do that. Full size channels. Huh? What the fuck are you talking about? What the fuck? That was weird. Didn't let me type. God damn it. What is it? Encoding. Where's the layout? It's encoding. Yeah. Size. I don't know why completion is completely screwed right now. That's very odd. Okay. Kill. God damn it. I wish it just highlighted everything. There we go. Oh, right. Sample size. Port. Fuck. What? Aw. I'm an idiot. Where was it? Where's the initialize? Okay. Might as well just move all of this here. Mix formats. What? What is this? Oh. Okay. Okay, so it doesn't work now. Probably because it was in a bad state, question mark? I'm not sure. What is this? Audio. What? God damn it. This is why I don't like doing this shit. It's just so easy to screw yourself over. There we go. Stop. Okay, that didn't work. Why not? Is it still stopped? Oh, good. Great. That's cool. Still here too. I'm guessing that stop might set internal state bits. That prevent it from doing other things while the actual initialization is just fine. Stop. I mean, typically you don't stop and start it, but it still should work, you know? So let's look at this. It's called stop on the thing. Stop on a server, please. Does what? Waits for the thread, destroys it, and that's it. Huh. Doesn't stop this. Doesn't stop the drain? What? That's no bueno. Or does that happen on exit? It might happen on exit. Unwind. It ends the segment sequence, which calls end on everything, I believe. Right. So it should do that. Yes. So no internal state bits. Weird. I wonder why it doesn't work then. Stop. Start. That's a very nice thing. That is beautiful. Okay. Audio client ID is what? No, okay. Found audio client now. Ah, boy. Do I not have those on file? I guess not. Alright, time to grovel some stuff. Manually, that is. Because I can't ask users to invoke a fucking C compiler. Fuck. Do I even have things? I do have things. Oh, God damn it. Fuck. Where's this shit defined? Probably Windows.h, probably. I wouldn't actually know. What was it? SOK rig to be class not rig. Okay. Class. Fuck! God, this is annoying. It's not actually a full screen, like a thing that stays on top. It's just rendered on top because Windows is fucking balls. Probably need to do right. Piss off. What are you talking about? Updates, my favorite. I bought my birds a new coconut yesterday because they were chewing through the string that it was hanging on, and I was afraid of it and I was afraid of it falling and scaring them. So I bought a new one, and obviously they got scared of me hanging it in there, so now they're still not used to it, even though this thing doesn't move on its own. They're fucking stupid idiots. I love them, but they're stupid idiots. I really wish they just would stop being so scared of everything. It doesn't even help them anything, you know? Yada-dee, yada-doo, yada-da-doo. Yada-dee, yada-da-doo. Jeez. I'm guessing that for some reason it doesn't like to reinitialize the or recreate the buffer in the device enumerator. I don't know why though. That seems very strange. Oh my god. Anyway, is elevator music its own genre? I feel like it should be. Hooray, we're done. Wait, actually, I want the... there's different fucking things. Right, MGW64, MGW64 thingy. Pam.
Pam-param, pam-pam-param, pam-param, pam-param.
God damn it. I really hope Cyberpunk is gonna have a Pamparam of its own. Something tells me it's not, but... Shh. 400 kilobytes per second? Come on, son. I got it fucking 100 megabit. Alright, I guess I won't be able to figure out what the fuck's going wrong on Gingy's computer. I guess I'm gonna have to try it out in a Windows 10 virtual machine, because that might make a difference. I don't know yet. That's the only clue I have right now. If it is, that's a real failing on Microsoft for compatibility, but who knows? Yada yada. Ba 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 da bum. As I said, like, in the process method, just print out, to start with, the process frames number, which should be constant, the frame buffer size, which might not be constant, and the frames to write, just to see how many frames Windows is giving you and how quickly it's processing things. That's gonna slow down output a lot, and it's gonna stutter a bunch, but that's the first clue about what's going on. The next thing to do is to look at the actual audio format that's being used. Process frames. The input argument. And the next thing is to look at the actual audio format that's being selected, which is in your code. It should be in where is it? Should be in initialize packed audio. Print out what kind of format it's specifying. So the sample rate, number of channels, and the sample format. Okay, right, so GCC A.C. What are you talking about? I just installed GCC. Fuck off. What? Why not? I just installed GCC. What the fuck? It should have a gcc.exe. What the fuck is this shit? Oh, it's the MSys console. Okay. That's Spade anyway. I'm not sure why I was having a shortcut to that. Here it is. Great. There we go. Now we're cooking. Yes. That's the ticket. Okay, are they longs? Is that what's going on? Also, I need a... boy. Is it ally? I always fucking forget how this shit works in printf. If you think format is bad, Jesus Christ, printf is the worst thing. No, it's what? How? Oh, god damn it. It was L. LU. Okay. Okay, H result. Here we go. Yeah. Two 147746288. Yeah, that's not a thing anywhere. No idea what that error is, because it's not specified on possible return values here. Nice. Oh boy. These numbers never change. Why is process frames 101? What? What? That's also not a multiple of frame buffer size. Is it? Yeah, no, that's not. What? That is very bizarre. Right. It is not one multiple, right? 4224. Yeah, it's not. That is very strange. Is it never getting a buffer from you? Do you know which of these branches is being entered? Like, there's 3 possible branches here. Can you see which ones are being actually entered at all? Because my gut feeling now is that it goes in here and then it never does anything because frames to write somehow ends up being 0. Goes in first and second. How? Something isn't right here. Yeah, I'm doing something wrong. Hold on, let me look at this. Yeah, this is not right. Process frames. No, wait. So the thing I'm doing here is that I'm releasing less than the total buffer size, which I believe is allowed. But in that case, frame buffer size should be 101, not 4224. This is strange. Where are you? Where are you? No, this is calling them min. So what? This makes no sense. Oh, wait. Hold on. Where are you reading the frame buffer size? Are you reading it at the beginning of the function? Because then it's gonna get... the frame buffer size is not gonna be the same thing. Can you print the 3 values right at the end of this first branch here? Like, print process frames, frame buffer size, and frames to write at the end of this branch, so in here. Okay. Frame buffer size and process frames should be the same size in that case, I'm pretty sure. All 3 have the same mass, right? So that's expected. Yeah. Not sure why process frames is so low though. Can you also print out the value of this block here? Which is the actual number of frames that the audio API is giving us to fill. Should also be important to know. because the standard buffer size is set to 441. So it should have a value of 441 rather than 101. Unless the buffer size was changed somewhere. Not changed anywhere here. Right. So that's what I expected, sort of. Why is it 101 and not 441 though? Makes no sense to me. Why is it 101? Are you sure the value of processed frames is 101? That makes no sense to me. How is that 101? 101 is not even a multiple of 441. What in the hell? At the REPL, can you see what, what this is? Harmony buffer size of Harmony simple server. Is that 441? How is it getting... How is it getting 101? How's it getting 101? Because process frames is only changed if it reaches the loss branch. And even then, it should be reset when it returns to the function. What? Oh. How is this possible? Where is the 101 coming from? Yeah, I know. But how? That's my question. It shouldn't be. It couldn't be. Ah, fuck you. Oh wait, no, it's mixing number of samples. Okay. Okay. Where's that set to 0? Where is that set? Is that set in... No, that's not set anywhere either. What? Where is that initialized? What? Okay, it sets it to the buffer size. That makes sense, but... So is... Is that also 4 for 1? Or 101, the samples? Or is that 4 for 1? Where is the 101 coming from? What? Am I getting insane? Where is that coming from? That's not possible. That's not possible. What in the fuck? Yeah, not started yet or something. Initialize. Oh, it's in. Is it in a fuck state? I don't know. It is 4 for 1 for me. I have no... The 101 makes no sense to me. That should not... That should not be possible. You, instead of an error, you can actually, like, much easier is to just call break if you want to invoke the debugger. So the around is getting... There's an around method on the process, so... Back train. Oh, it has a remix factor. That's also probably why it sounds so garbage for you. Because it wants a different sample rate. Oh, interesting. Why is the sample rate for you different? Okay, can you let me commit this real quick? Fuck. Wait, I can't commit here. I forgot. Fuck. Yeah. It has a remix factor, so the sample rate is different. Can you hold on in the so the I think that's the drain. Is it not in the server? Server device is what it's called. Okay. Okay, can you call this and see what the sample rate of the packed audio is? So you have a much higher sample rate. Yeah, that's what I expected. The question is why? Because we specifically request a lower one. Why, Windows, are you not giving us the sample rate we ask for? What you can try doing, I don't know. You could try changing the sample rate of Harmony to match yours, but one, the server should really accept the sample rate we ask it, and two, the conversion of sample rates should be fine. Should actually work, as far as I'm aware. But that's probably the sample rate conversion is what's causing you to just hear noise. So it's not actually within the WS API thing, aside from it not picking the right sample rate for whatever reason. Yeah, the question is why. Well, anyway, it's too late for that. But hey, we got some idea of where problems lie, so that's good. I'll commit these things as soon as I'm on a machine where I can commit things. I can't do that here because I don't have my Git stuff set up. Anyway, that was, I guess, somewhat successful. But yeah, okay, alright. Thanks for sticking around, and see you again next Sunday. Bye-bye.